Good morning. Today is October 2nd. We're going over the science skills test. Question number 1, I discounted. Nobody had to answer that one because it wasn't written properly. It should have said, which is not a safe procedure to follow when using glassware. Question number 1 and 2 are very similar, so it didn't matter if you didn't do question number 1. Question number 2 was important. Which of the following is dangerous to do in the science lab? So, generally, when we heat things, we have to point them away from ourselves because heat makes things expand and they'll move quickly. So if it's pointing toward us, that we run the risk of something getting blown in our face. You always have to use goggles when we use glass or chemicals. And if you are using a hot plate and you walk away, that's dangerous because that could cause a fire. And definitely wash your hands. So number 3. The picture to the right shows wafting. Some of you got this wrong because you didn't know what the choices meant. So you need to write this in your own words. So somebody give me what wafting means in your own words without even looking at the choices yet. What does it mean to waft? What does wafting mean? What are you doing when you waft, Vincent? Isaiah, help him out a little. Good. So you have to, she said we're smelling it, but we're not putting it to our face. So what are we doing to the air, Lynette? So when you waft, you're actually doing what to the air? You're pushing the air toward you. So you're getting a little bit of the gas or whatever you want to smell. You're turning the gas, whatever molecules are in the gas above it, you're pushing toward you so you don't smell it directly. So that's what you wanted to say, indirectly smelling it, right? So wafting is smelling safe. Safe smell. If you got this wrong, I need to know, well, you need to know what you picked. Flammable. If you got this wrong, or even if you got it right and you guessed, please annotate. That means I want you to write what flammable means. That means it could go easily on fire. If something's flammable, it could go on fire. So you want to wear clothes to bed that are not flammable. So they're flame retardant, they're called. So they slow down. Radioactive. When something's radioactive, it gives off gamma radiation. It gives off waves of energy that are dangerous. Dangerous waves of energy. Irritating vapors. If you're irritating something's irritating you, it's going to annoy you and maybe possibly even give you a rash, or it scratches you, or it hurts you. Irritating is not a good word. It's scratchy. It's annoying. So, or it could be pungent. It's yucky. What's a vapor? Like water vapor. What does the word vapor mean? A vapor is a gas. So if you did not know this, and some of you I actually helped with this, write it down, annotate it. You might see those words again. And stain your clothes. So at this point, what's the correct answer? What is wafting, Logan? Good. So which choice means that? Good. Because this is safe to use because some chemicals can give off irritating vapors. They give off annoying gases. They give off dangerous gases. Irritating is going to harm your nose. It's going to like scratch your nose and maybe even hurt the cells. Are we good with these? Okay, next page. Or for me, it's next page. Scientists use instruments. An instrument is also a tool in science. So if you didn't know the word instrument was a tool, write it down. Because some of you might know the science, but didn't know the other vocabulary. So what's the correct answer here, Joseph? Do instruments help extend the senses? Is it true or false? Is that correct or not correct? Help extend the senses. So my sense of sight or my sense of touch, my sense of hearing. If I use an instrument, can I hear something better sometimes? Is there any instruments that make me hear things better? Are there any instruments that help me see things better? Are there any instruments that can help me feel things better or like understand the mass of something? Yes. So instruments can extend your senses. Can an instrument help me collect data? Yes. Can an instrument help me make accurate observations? Yes. So what's the answer to this? All the above. Sometimes I hate all the above because then it's like tricky, right? You got to make sure that all of them are true. Yes, sir. Oh, if you say this is light, I put it on a triple beam balance and I'll know exactly what the mass is. So not feel it better, not texture-wise, but understand mass and perhaps volume. Okay, observation inference. An observation is a fact. You use your five senses or a measurement. An inference is your opinion, a prediction, or your guess. It's your conclusion. Knowing that, if you didn't know that, write it down. The air temperature is 75 degrees Fahrenheit today. Most of us got this right, but if you didn't get it right because it's an exact measurement, observation. Somehow you reverse these. The fossil is 50,000 years old. That's an inference because we were not there to see it. It will be sunny. Will be is a prediction. That's also an inference. During a laboratory activity, a student combined two solutions. In the lab report, a student wrote, "Oh, blue color appeared." Blue color is a physical property. When this statement represents the student, they recorded their observation because I can see it with my five senses. If you got this wrong, please write down why that answer is correct. You need to annotate. If you want to take a test over, you need to make all these corrections on your test. A scientist had asked a question about the effects of smog on plant growth. What should they do next? So the first step is to ask the question. What's the second step in the scientific method? What do you do second? Delaney. Yes, you collect information. So in your notes, it said gather information. If you got this wrong, please write that. Collect and gather means the same thing. You needed to use your notes for this one. Which set of items could help you make an observation? So the words had to be either your five senses or an instrument. Instrument. Uh-oh. Instrument. I had like a moment where I couldn't see how to spell that word. All right, so sight, that's a five sense. Ruler, that's an instrument. Stopwatch is a instrument. That one's good. Sight, is graph paper an instrument? No. Calculator an instrument? Okay. Sight, touch, textbook. No. Touch, ruler, notebook. No, that's what we collect data. That's how we do research. So the only answer that could be correct is number 1. A lot of people got that one wrong. This is one that I looked at to see if you were a 3 or not, because you had to really infer. First step in the scientific method, after this paragraph. You didn't even need to read this paragraph to get the first one, but you had to know what the first step is. What's the first step, Ava? Good, state the problem. The information the student recorded is called what, Will? Yeah. Number 12. That is correct. Now, up to 12 is a 2. Now, from 13 on, this decided if you were a 3. If you got most of these right. If you only got one wrong, then you could have been a 3. The dependent responding variable. In this paragraph, a student wanted to know if changing the temperature of her green bean plants would make them grow taller. She planned an experiment on the growth of green bean plants. She grew the green beans in 4 separate pots. Each pot was placed in its own incubator. A box that controls temperature. I told you what incubator was. The incubators were kept at different temperatures. All the conditions were kept the same for each plant. The heights of the green plants were measured and recorded after 2 weeks. What is the dependent responding variable? What's the data we're going to collect? If you don't know this, you need to write this. Data collected. What's going to happen? What's happening in this experiment? What are we testing this experiment on that we're collecting the data? What's happening? What's responding in this experiment? What's happening? What's responding in this experiment, Logan? Good, the plants are growing. So we're going to measure the height of the plant. That's our data. Every experiment needs, well, not every, but most experiments need a control. Why do we use a control, Jared? Do we need a control to make a comparison? Do we need it to give scientists a clue? Do we need it to make the experiment more complex or more interesting? Somebody tell me which two we can cross out automatically because they're really not good choices. Which two, Anthony? Yeah, really? That's not why we need a control. So we definitely can cross that one out. So now we only have 3 choices. What else can we cross out? Give the scientists a clue, right? That's silly. So now we're left with 2. What is a control needed? Your control is your, what's the word I taught you? It's your baseline. This is the information we know when we start. So why do we use a control? We use a control so we can make a what, Logan? A comparison. This is what you know in the experiment. I know this is going to happen if I do this, but I don't know what's going to happen with the other things. So I'm going to compare everything to this one. If I use fertilizer, then the tomato plant will produce more fruit. What's the thing we have the power to change? They're asking for the independent manipulated variable. What am I testing? What am I changing? What is being tested? What's the experiment based on? What's the experiment based on, Dominic? Do I have the ability to change the tomato plant's height? Can I do that? No, so I'm not changing that. Do I have the ability to change the amounts of fertilizer? Is this what I'm testing? Is this what I'm changing, Lynette? Yes, that looks like a good one. Do I have the ability to change the number of tomatoes? No. Do I have the ability to change the amount of water? I do, but I don't because is this what I'm testing? No, I'm testing actually the fertilizer. So this is the correct answer. If you're still not sure with independent and dependent variables, I have a worksheet that I'm going to make a video for so you guys can practice because the next test you need to know it well. 16, 17, 18. A lot of people got 16 wrong. Let's look at it. Even if you got a 4, you could have gotten 16 wrong, so you need to know it. A group of people was used to test the effectiveness of a new toothpaste compared to their regular. So this group of people that was designed in this experiment is testing their new toothpaste and their regular. That's what the sentence says. Which of the following represents a controlled test? Controlled test means we can only change one variable. So have everyone in the new group brush with the new toothpaste. Well, that's good, but then what are they comparing it to? We don't know. So that's not a full statement. Have everyone brush with both their regular and their new. Is that good? That looks good so far. Let's see. Have half the group brush with the new toothpaste and half brush with the regular. If half of the group brushes with the new toothpaste and half brushes with the regular, can we compare? Everybody's teeth is different. How do we compare? You can't compare with this one because everybody, it says they have to test the effectiveness of the new toothpaste compared to their regular. So they have to test it and compare the new to their old. So everybody has to be in this test. This was a hard one. Half the people brush their teeth with the new toothpaste and the other half don't brush their teeth. That one's silly. So the answer is choice 2. If you got this wrong, it was a little bit tricky. In an experiment designed to test if dogs prefer a specific shaped food, what's the only thing we're allowed to change? The shape of the food. So we can have different shapes. So we know 4 is wrong. If we have different shaped food, that means everything else has to stay the same. So you can't use different brands of dog food. You have to use the same color, too, of dog food. The only thing you could change is the shape, choice 3. Number 18. Base your answer to the following question of the 2 companies that make baseballs. Each claims that their ball travels farther. A baseball player hits the ball and measures how far it goes. That's not going to be good evidence. You know why? What's going to happen to him, Peter? Yeah, they all hit differently. They all have different force, a different power. So we can't use a baseball player because he can get tired. So that's not going to work. We need to use a machine. that measures the same force and could measure how far it goes, so that we have everything is the same except for the baseball. Can we read a survey that's already conducted or results and set up our own survey? No. All right. So this page, if you got 16, 17, 18, right? Then you probably got a 3. If you didn't, you're still on the 2 range. However, the next page could give you a 3 if you got this whole page right. I wasn't worried so much about 19 and 20, but I was more concerned about 21. So let's look at it. If an electrical fire broke out in the classroom, which equipment would Miss Samuelson use, and explain your answer? So there's lots of correct answers. Destiny. We could use the fire blanket. Good. Why? Yes, you're going to smother it. What else could we use? Tell us why we can't use water. Right. If you use water, you spread the fire. So you could use a blanket. Can't use water. What else, Trinity? The sand. Perfect one. The sand will smother it. And then the last one, Peter? Yes, you're right. Fire extinguisher. So you cannot use water because it will. Do not use water. Makes the fire bigger. It will spread the fire. You must smother it. Do not give it any oxygen. You want to smother it. You want to put it out by using either a fire blanket, the sand, because the fire needs oxygen. Once you deprive it of oxygen, then it won't continue to go. Or the fire extinguisher. We need to smother it. I'm just abbreviating so we can move forward. All right, next question. This is the question that really determined if you were 3 or not. If you were able to get all 3 of these correct. So, Patrick believes that fish that eat food exposed to the microwave will become smarter and will be able to swim through a maze faster. He decides to perform an experiment. He places the fish food in the microwave for 20 seconds. He has the fish swim through a maze and records the time it takes for each one of them to make it to the end. He feeds the special fish food to 10 fish and the regular food to 10 fish. After 1 week, he has the fish swim again and records the time for each. What is the manipulated variable? What is he changing? What is he testing? What's happening here? Haley, what is he changing in this experiment? What does he want to know? So the independent variable is what's actually being changed. Yes, he's changing the food. So the fish food, if it's microwaved or not, but the answer food is appropriate. 3 things that he must remain constant. Has to be the same. What has to be the same? Good. The maze has to be the same for each and every one of them. What else has to be the same? Asaya.
The time that he feeds the fish.
Yes, the time he feeds the fish. Every day they have to have, the time has to be the same. Time, fish are fed. Some people put time, and you didn't explain. I don't know what that means. Time, fish were fed, because the time that they go through the maze, we can't control that. That can't be constant. Look at the numbers. They're all different. So you had to be really specific. Madeline. Yes. Same amount of food. Good job. They all had to be the same species of fish. You couldn't have all different types of fish. They had to be in the same size tank. Things like that. Which group is considered the control group? And then you had to explain why. If you got these wrong, you guys have to annotate. You have to write down little clues for yourself. Which group is the control group? Which group is the control group? Good. The regular food, the fish that had the regular food. Because that's going to be our baseline. We want to see if it actually makes them smarter if they have the other food. It's used for comparison. So we want the regular fish food fish to be our control group because we never changed anything with that. Stays the same. So the only thing that changed was the microwave food. So the regular food is the control because we didn't change it. and it acts as our baseline, acts as a comparison. This is what we know. We use it as our baseline, and then if they do finish faster, we know that that food helped. If they don't, then we tested something different. All right, this was the hard one. If you got this all correct, that's where you got a 4 on the first standard. You didn't have to get this right to get a 4 in the second standard. Hurry up. A rattlesnake bites a mouse and injects poison into it. The rattlesnake then allows the wounded mouse to run away. But after a while, the rattler follows the trail of the wounded mouse. Although the rattler cannot see well, somehow it manages to find its victim on the dense, dark forest floor. Clearly, something leads the snake to its prey. What invisible trail does the snake follow in tracking down its bitten prey? To try and solve this mystery, scientists performed an experiment. They let a rattlesnake bite a mouse, and then they dragged the mouse along the curved path on the bottom of the empty cage. When the snake was placed in the cage, it followed the exact trail. This is what we know already. We already know this. So this is the control. This is what we already know. When we do an experiment, we want to test other variables. Put your hand down for a second. To make sure it was the scent of the venom and no other odor, the snake followed. The scientists ran another experiment. This is what they're changing. This is the new part. The scientists dragged an unbitten mouse along a curved path in the snake's cage. This time, they seemed disinterested. It didn't follow the path. After analyzing the recorded data, the scientists concluded that the scent of the venom was the only factor that could cause a rattlesnake to follow its bitten victim. So what was the manipulated independent variable? What did they change? What were they testing? What do they want to find out? What changed?
If it would follow the trail
Of what kind of mouse? We already know, right, non-venomous. So the independent variable, what they changed was the actual mouse, whether it had venom or not, with venom or no venom. So what they were testing, venom, was the mouse without the venom. So the control group in this case isn't the unbitten mouse, it's actually the bitten mouse. So when I was grading this, some of you should check, because I don't know if you really got it right. If you didn't get this right, you need to fix this for number 26. The control group was the mouse that was bitten, because that's the one we already know. We know what's going to happen with that one. The experiment was going to give us some information. Now, this is the part, 27, 28, 29, 30. You had to come up with your own question related to this. Some people had good questions. Can other animals do this too? Do they follow the trail? If a cat kills something, does it go back to it and know exactly where it is? What about, how do bats find their prey? I don't know. We have to make a hypothesis. Does anybody think they wrote a good question? Can I hear yours, Logan? Right. Okay, so even species. Is there a certain species of animal or a rat that a snake prefers? So there's questions that can extend this. When you ask a question to extend it, it really should be something to make our world better, right? Yes, it has. Generally, because we're so egocentric humans, we want to do things to make ourselves better. So then we could breed those mice and sell them if they like something better, right? Because generally we breed the albino mice or the albino snakes, and that's what we give to the not snakes, albino rats. Do they like them better than brown? We could ask that question. And if they do, then the pet stores are going to have to make more brown mice so they can sell more. So propose a question that would be answered that could extend your research or relates to it. That's a good question. Do snakes prefer brown or white mice or rats? Do they have a preference? We don't know. You could test it. What would your hypothesis be? If the snake eats a brown rat, they will prefer it. They'll eat more of them. They'll eat more brown than white rats. The manipulated variable is going to be the color of the rat. That's what we're testing. And the dependent variable is how many they eat. We're going to count. And that's how we're going to test. That's the data. How many brown they eat, how many white they eat. We're good? Okay.